Unit 7, Day 5, Geometric Sequences. Today you are going to be able to recognize and graph geometric sequences. You're going to be able to find the nth term of a geometric sequence. In a geometric sequence, the ratio of successive terms in the same number, r, is called the common ratio. Each term is found by multiplying the previous term by that common ratio to get to the next term. So you can see in this example, to go from 1 to 3, we multiplied by 3. From 3 to 9, we multiplied by 3. From 9 to 27, we multiplied by 3. So the common ratio is 3. So is the sequence geometric? So remember, in order for it to be geometric, we have to be multiplying by a common ratio. So how do we go from 120 to 60? Well, some of you would say minus 60, but then how do we go from 60 to 30? We subtract 30. So because it's subtracting, and they're not the same, okay, we want to see, can we multiply by something to get to the next term? To go from 120 to 60, we can multiply by 1/2 or divide it by 2. To go from 60 to 30, we can divide by 2, which is the same as multiplying by 1/2. To go from 30 to 15, we again can multiply by 1/2. So we would say, yes, this is a geometric sequence. When we take a look at the next pattern, to go from 4 to 8, we multiply by 2. To go from 8 to 12, we can't multiply by anything, so we would say this is not a geometric sequence. There is no common ratio. So let's write the next 3 terms of the geometric sequence. So we go from 3 to 6. To go from 3 to 6, we multiplied by 2. 6 to 12, we multiplied by 2. 12 to 24, we multiplied by 2. So 24 times 2 is 48. 48 times 2 is 96. And 96 times 2 is 192. So in part B, they ask us to graph that sequence. So remember, when we're graphing, we are graphing ordered pairs. These are ordered pairs from our T-chart. So you want to make sure and label 1, 2, 3, 4, 6, 7, 8. Okay, and then on this graph, we can count by 3s, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, 51, 54. And then we can plot this information on our graph. So 1, 3, 2, 6, 3, 12, 4, 24, 5, 48, 96 is off of our graph, and so is 92. What does this graph look like? You're right, an exponential function. It increases with a quick curve. So if we write the next three terms of the geometric sequence and identify the common ratio between them, To go from 1 to 4, we multiplied by 4. 4 to 16, we multiplied by 4. So to write our next three terms, we would do 64 times 4. So we got 256. 256 times 4 is 1,024. 1,024 times 4 is 4,096. The ratio is multiplying by 4. Term 1, term 2, term 3. The next three terms in the next sequence, how do we go from 2 to negative 6? We multiply by negative 3. 6 to 18 times negative 3. 18 to 54 times negative 3. Negative 54 times 3 is positive 162. 162 times negative 3 is negative 486. And if I multiply negative 486 by negative 3, I get 1,458. So our ratio is multiplying by negative 3. To go from 512 to 384, we're decreasing, so I know I want to use a fraction. So the most common are 1/2, 3/4, 1/4. So if we do 512 times 3/4, we get 384. So we know our common ratio is going to be 3/4. When you're going from a larger to a smaller number, you're always going to be multiplying by a fraction. So 288 times 3/4 is 216. 216 times 3/4 is 162. 162 times 3/4 is 121.5. To go from 9 to 3, we divide by 3, which is the same thing as multiplying times 1/3. So our common ratio is to multiply by 1/3. 1/3 times 1/3 is going to give us 1/9. 1/9 times 1/3 is 1/27. And 1/27 times 1/3 is 1/81. So write an exponential function that describes a geometric sequence. So in order to write a geometric function, we can look at our n values, or the positions. We want to look at the terms. We want it written using a sub 1 and r, and then we can plug in numbers to look at it. So if we let a sub 1 equal 1 and r equal 5, our position, or the first term, is a sub 1. And we know that equals 1. We then look at the second term and we multiply our a sub 1 by our common ratio, which they told us was 5, to get the number in our second position is a 5. We multiply by r squared, so 1 times 5 squared gives us 25, which is the same thing as if we multiplied 5 times 5, or our common ratio, we would get 25. So then each time we raise our ratio to a power, the next higher power. So if we're looking for the nth term, so we don't know which position we're going for, we can use a sub n as our term, So we take our first term times our ratio raised to the n minus 1 power, so whatever term number they give us, we're going to replace our n with that to fill in whatever the next number is. So if you have a sub n, it is equal to a sub 1, so your first value, times the common ratio raised to the whatever you're looking for minus 1. So in the last example, they say write an equation for the nth term of the geometric sequence. So remember, we're going to use the formula a sub n is equal to your first term times your ratio raised to the n minus 1 power. So they told us the first term is 500, so we label that a sub 1. The common ratio is 0.2, so this is our r. What is the seventh term? So our n is 7. So we're looking for a sub 7, or the seventh term. We know we start with 500. Our ratio is 0.2. Our n is 7 minus 1, and then we simplify. 500 times 0.2 raised to the 6th power is going to tell us what our seventh term is. So type that into your calculators using your parentheses as necessary, and you should get a sub 7, or your seventh term, is 0.032. Let's try another one. What is the ninth term? This time they gave us, so our n is 9. This time they gave us a sequence to look at, so we need to recognize that our first term is our a sub 1, but we need to ask ourselves, what is the common ratio? How do we go from 2 to negative 6? We multiply by negative 3. Negative 6 to 18. We multiply by negative 3. So our common ratio, or our r, is negative 3. So we're looking for the ninth term, a sub 9. We start with a value of 2. We figured out our common ratio is negative 3. And we are looking for the ninth term, so we take n minus 1. We can rewrite that as a sub 9. 2 times negative 3 to the 8th power, and when you type that into your calculators, you should get that the ninth term would be a sub 9. The ninth term is 13,122. 13,122 would be the ninth term in the geometric sequence. You can now complete Day 5 worksheet.